Hello. In this video, I'm going to introduce you to three different solution concepts for a strategic game, or for any game for that matter. The information in this video can also be found in written form in a handout that's included in the appropriate Blackboard folder for our course. The first solution concept that I'd like to introduce is prudential. Prudential strategies are conservative. And by that we mean that they want to maximize the minimum that a player will get as a payoff. They're trying to do the best that they can do regardless of what the other player does. So to calculate a prudential strategy, what we do is we pick a player, Rose, and we look at her outcomes in each of her three strategy choices. So in top, her worst outcome is 2, this 2 right here. In middle, her worst outcome is 1, and in bottom, her worst outcome is 0, and she wants to maximize those minimums. So what we see is that Rose's prudential strategy is top with security level two. And by security level, what we mean is she knows that if she chooses this strategy, T, she will guarantee herself a payoff of at least 2. If she chooses any other strategy, her payoff could be better or it could be worse. We do Collins' prudential strategy the same way. The worst he can do in this column is a 2. The worst in this column is a 0. The worst in this column is a 1. The worst in this column is a 1. And the biggest of those is a 2. So Collins' prudential strategy is A with security level 2 as well. But if Rose looks at Collins' choice of strategy and says, well, he's going to play his prudential strategy A, instead of playing top, I'd rather play bottom and get a payoff of 7. Colin says, well, if Rose is playing top, instead of getting a 2, I ought to play D so I can get a 3. So what we're seeing is this pair is not stable in the sense that each of the players regrets their choices or second guesses what their choice is of a strategy. A solution concept that resolves this problem of stability is the Nash equilibrium. The Nash equilibrium is a pair of strategies which are best responses to each other. And I'll illustrate that carefully as I calculate our Nash equilibrium. But first I'd like to point out that it's a pair of strategies. They always come in groups, one for each player, whereas a prudential strategy is a choice by an individual player. So how do we calculate a Nash equilibrium? Well, what we do is we find best responses. So in the top row, If Rose is playing in the top row, Colin's best response is to choose D. If she's playing in the second row, his best response is either B or C. And if she's in the third row, his best response is C. Conversely, from Colin's point of view, if Colin is in column A, Rose's best response is B. Her best response to column B is row M. Her best response to column C is row D, T for a payoff of 8. And her best response to column D is row T for a payoff of 2. And since a Nash equilibrium has to be best responses to each other, we have to choose the places where they have been marked twice. So our Nash equilibria are TD with payoff two, 3, and another Nash equilibrium is MB with payoff 5, 4. Now I reiterate, if we are at this Nash equilibrium right here, Colin says, I'm getting 3, can I do something different and get a bigger payoff? And the answer is no. That's the best he can do given what Rose is doing. This is stable. These are stable. So one can ask, how do we choose, or how do we get from this one to this one? How can we guarantee we get the bigger Nash equilibrium? And the answer to that falls in a single word, which is cooperate. If you choose what you're doing together, then you will get the bigger payoff. But wait, we can still get a bigger payoff. If we're cooperating, instead of getting a 5 and a 4, we can get a 7 and a 5. So cooperating should get us to the payoff, the strategy pair BA with payoff 7, 5. And this payoff is actually the best in some sense if you cooperate, because if you're here and Colin wants to increase his payoff to the 6 or the 8, Rose's payoff would have to go down, right? So this is sort of the best cooperative solution they can get to. It maximizes what both players are getting. And for one player to increase their payoff, the other must decrease the payoff. That payoff has a name, that solution idea, and that is Pareto optimal solution. Optimal solution. It's the solution where you've optimized and made both players' payoffs as big as they can be together via some sort of cooperation or collaboration potentially. Well, unfortunately, this is not stable. So they can cooperate and say, we're going to do 7, 5. But Colin, sneaky, when it comes right down to it, could choose C. And so there is room for non-stability in here. This stability in a Nash equilibrium is self-reinforcing that we don't have over here. In some games, these three concepts, prudential, Nash equilibrium, and Pareto optimal, are all the same thing and give us the same solution. Sometimes 2 out of 3 are the same, and as you can see here, sometimes they're different. But this is the basic idea for each of these solution concepts. Thank you.